Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Yeah,
Good afternoon, sir.
good afternoon. Okay, so we can start. Let me.
Sir,
Yes,
sir, can you take attendance right now because by evening, due to heavy usage, the network in some areas get very bad. So,
yes, yes, yes. I can take. Yeah, sure.
okay,
Just a
thank you,
minute.
sir.
Yeah. Okay. For aerospace, 25 absent, 26, 27, 28, 29 absent, 30 present. Then civil 77 present, 78 absent, 79, 80 present, 81 is absent, 82, 83, 84, 85, 86, 87, 88 present, 89 is absent, then 90 is present, 91 absent, 92 absent, 93 absent, 94 present, then 95 present. CST 58 present, 59 present, 60 absent, then 61 present, 62 present, 63 absent, 64 present, 65 present, 66 present, 67 present, 68 present, 69 present, 69 is okay, 70 is absent. Then electrical 49 absent, 50 present, 51, 52, 53, 54, 55 present, 56 absent. Then 57 present, 58 present, 59 present. Then electronics 35 absent, 36 present, 37 present, 38, 39, 40 present. Then 41 absent, 42 absent. IT 53 absent, 54 present, 55 absent, 56 absent, 57 present. Then 58, 59, 60, 61 present, 62 absent, 63 present, 64 present. Mechanical 49 absent, 50 present, 51, 52, 53, 54, 55, 56, 57 present, 58 present, 59 present, 60, just a minute, 60 absent. Then metallurgy and materials 25, 26, 27, 28, 29 present, 30 absent. In mining 25 present, 26 absent, 27 absent, 28 present, 29 present, 30 present. 1 second. Those who are absent, aerospace
Sir,
20.
CV089 present. I joined 2 minutes late. Sorry, sir.
Just a minute, I'm coming. Those who are absent, if you are present, you tell me at that time, okay? Okay, aerospace 25 absent, then 29 absent, then civil 81 absent,
So, civil
then
81 present, sir.
81 present, then civil 89 absent.
Present, sir.
Yes. Then
89 present.
yes. Civil 91 absent. Then computer science 60 absent. Then computer science 70 absent. Then electrical 49 absent.
Sir, electrical 49 present.
Electrical 49. Just
Present, sir.
your name?
Divyansu Poddar.
Yeah, present. Then electrical 56 absent. Next is electronics 35 absent, then electronics 42 absent, IT 53 absent, 55 absent, 56 absent, then
56
IT,
present, sir.
just a minute,
IT 56.
IT 56, Rahul, present. Then IT 62 absent, then mechanical 60 absent, then mining 26 absent, 27 absent. Okay,
Sir, mining 27 present.
mining 27. Shadows, mining 27. Yes, given. Okay. Somebody, 64, CSB 64. Just a minute. 64, CSB 64 present. Yes, given, present. 64 present. Yeah. CSB 54 present. That's all. Okay. So attendance is over. Now,
So,
yes,
sir, I actually have one more request from our batchmates and myself.
yeah.
Sir, actually, in this week, we have our vivas, and tomorrow itself we have our test. And
Mm,
we every day we have 2, 3 assignments due.
mm,
So if you could postpone the test by
just
1 week, it would be helpful. And moreover, we have 4 sheets coming in that test, and
okay.
even those sheets are due on 25th. So if you
And
could
sir,
do,
actually, we have got the new official notice that the whole SEM will be online for us
Mm,
first years.
mm.
So, if it is possible, could you please
Yeah, yeah.
postpone?
We can do that. Let me check then. Okay.
Sir, from 18 April we have final set for exam instead of 7.
Is it
Yes, sir.
that
Previously it was 7, now it is 18.
I have not checked? No, you got notice that one?
Yes,
yes, sir,
sir.
we
Yes,
got
sir.
Yes,
notice.
Notice.
sir, we got a notice, official notice.
Our
Oh,
entrance has been postponed. So
ha
if
ha
you could
ha.
take the test on 22nd, it would be great.
Just a minute. Let me check that. 1 minute. From what you got from website, correct?
Yes, sir,
Yes,
on
sir.
website.
Student section notification.
Okay, just a minute. Now I'm opening. Let me check it. So notification student uh, first semester online mode answer we held offline. Okay, just a minute. Okay, that means everything will be online mode and first semester, first year students will be give. Just a minute. So first semester shall be continued in online mode. There shall be no any offline classes for first semester Btech and BArch students. And what is the exam? Okay. However, their end semester shall be offline mode from 18, correct? 18/4. Let me check. April 18. Okay. From April 18 onwards. That means we are getting some time, correct? Let me check once again. Earlier date was from 7th. 7th has moved to 18. Okay. 7 has moved to 18. So we are getting 1 week extra. Okay, fine. So what we can do, let me cover the syllabus first. Okay. Let me cover the syllabus first, then, or maybe after some days we will decide which date we can. As you told, which date?
22nd, sir.
Okay, 22nd is preferable, correct? Just a minute. 22nd, 22nd, April. Just a minute. So you told March, instead of 7th April, it is from 18. From 18. Okay. Then you want which date? Which date exam you want?
Sir, 22nd only.
Just a minute. March 22nd. Okay. Is there any issue for anybody for 22nd?
No, sir, it is okay.
Okay, then let it be 22nd only. I have to note it down. 22nd. 22nd March 2022. Class test 2. Any student is having any issue? Then you can tell me. Otherwise, it is 22nd.
No, sir, no
Okay.
issue.
Yes, yes. Then 22nd. Okay. As we are getting some time, it is good for you. But as per my plan, I have planned to complete the syllabus by. Let me check. You told it's 18. So maybe we can continue the class up to this April 8 in that case. 1 week may be okay for you. Okay. So 1 week
So we
before.
are called on campus on April 6th. So I guess 3-4 days would be off so that we can travel.
Then what I'll do, I'll complete the syllabus by April 1 itself. That is better.
Yes, sir, that is better.
Yes, sir.
Otherwise you are from different places. You have to come from there, and a
Yes,
new
sir.
place, your system, accommodation, everything will mess up. As we are ahead of the syllabus, not ahead, somehow we are managing the time. Okay, that's it. So it's okay. By April 1st, I'll cover the syllabus. Okay, as per our schedule, as you told, you have to come here by 6th, correct? It is told
Yes, sir. 6th
that
onwards.
6th onwards. So hopefully we will start traveling by that April 2 or 3, I guess, correct?
Yes,
2 or
sir.
3, you will be busy. So let it be. The target is by April 1st, syllabus will be over. Okay?
Okay, sir. Thank you.
Yes,
Okay,
sir.
fine. Very good. Okay. Now,
Thank you, sir.
yes, yes. Welcome, welcome.
Sir, could you please mark me present? I joined late due
Yes,
to network
just a minute,
connection.
just a minute. Okay. Your roll number?
Sir, ITB 55.
Just one. IT 50.
55.
Name?
Devashish Gupta, sir.
Devashish. Okay. Devashish. Ha. Okay, fine. Given.
Sir,
Now,
an electrical 2, 58 roll number.
electrical. 1 minute. Which place? Electrical. What is the role?
58.
558. Yeah, Niha, correct?
Yes, sir.
Okay. Given. Ha. Let me tell once again those who are absent. Aerospace 25, 29, then civil 91, civil.
Hello, sir. Mechanical 60.
Just a minute. CST 60 absent, then CST 70 absent, then electrical 56 absent. Electronics 35 absent. Then electronics 42 absent. IT 53 absent. Then IT 62 absent. Then mechanical, what you told? 60. Hello?
Yes, sir. Mechanical 60.
Yeah, yeah.
Yes, sir.
Given. Last day you are absent or present? You are absent. Last day?
Sir, yes, sir. Last day I was absent.
Okay, fine. Then who is absent? Mining 26. Okay, fine.
Sir, mining 26, sir.
Present, correct?
Yes,
Mining
sir.
20. Your name?
Vicky Kumar.
No, Vicky I have given. Sorry. Mining 27 is absent.
Okay, sir.
27.
Sir, 27 present, sir.
27 present. Then all all students are present. Okay, that is over. Now,
Okay.
yeah, all are present. Now let me come back regarding this. Let me share the screen.
Sir, is there a holiday next Friday because of Holi?
Yes, yes. 18 is holiday.
Okay, sir.
I think I have given that in your classroom also.
Oh, yes, sir. Yes, sir. Yes,
You can
I
check that.
remember.
Okay. Yes, yes.
Okay, sir. Thank
Because
you.
I have noted that is holiday. So what is the plan? Say today, your this uh, kinematics will be over. Then next Friday I'll start kinetics. Okay. So that is the plan. And exam, as you told, 22 will be the exam mid semester. Then I will get 1 to 2 days extra before that class test for kinetics. Now let's come back. You tell me what are the problems you are facing the issue. You need help from me. Starting from problem sheet 1, then 2, then 3, and then 5. What are the problems I need to address you? Let me know.
One finished, sir.
Huh? Hello? Are you able to see the screen now?
Problem sheet
Yes,
one
sir.
completed.
Problem?
It's
Problem sheet
completed,
one we have
sir.
discussed.
Problem sheet 1 completed.
No, no. Problem 1 is completed.
Sir, you did
We have
all the
discussed.
problems in
Okay.
previous
But
class.
still, yeah, I forgot. If somebody is facing some issue, you can let me know. Problem sheet 1. Anybody is having any issue for problem sheet 1? No, correct?
Sir,
Then problem
3.
3, I have told this is the something wrong here. It is 2. Okay. You are looking
Okay,
for
sir.
this. This data was wrong. 2.
Sir, but I submitted, it was 12. I
No
put
problem.
12
Don't
and
worry.
submitted.
Don't worry. Then if you take 12, answer will be different. No problem.
Yes,
Okay.
sir.
Yeah. No issue at all. Fine. So any other problems? Problem sheet 1?
No,
Sir,
sir.
7.
7.
Sir, 6.
6. Okay, 6.
6, sir.
Okay, 6. Then 7.
Sir, not 7, sir. 1 second, can I explain 8, sir?
8 I cannot explain. That is done. You take help from your friend. 8 is done. It is already done. I cannot do once again. What about 6? Should I explain once again 6? 6 I have to do. 7. 7 is okay.
Okay, sir.
Now 7 do you want or it is done? It is up to
Done, sir.
done.
Done.
Okay. Then 6. 6 was
Done, sir.
yeah. Fine. So 6 only. Then I can write 6 only. So I can note down here 6. For this, one body is falling with a speed v0. This is one body. It is falling with speed v0 and strikes and maintain contact with the platform supported by nest of spring. This will hit here. This will hit here, and it is supported by nest of spring. Perhaps minimum there will be 4 spring. If I see top view, there will be minimum 4 spring. From the side, we are looking for only 2. Understood? So maybe this is the platform, and inside there will be some minimum 4 spring, maybe more than that, maybe 6 also. If I look from this side, or maybe 8 also. That's why it is nest of springs. The accelerations of the body after impact is acceleration A equal to G minus Cy. C is a positive constant and Y is measured from the original platform. So this is the original platform, this is the Y. And V0 is the initial speed. And acceleration is a function of Y. Acceleration is a function of Y. If the maximum compression of the spring is observed to be Ym, so when this body will hit this and vertically downward displacement, then definitely the spring will compress, and the maximum compression of the spring is observed ym. Can you just try to imagine there is one platform and this body will hit there and you will be getting, and the spring is compressing some, it will compress, and when you will get this maximum compression, when you will get this maximum compression, what will be the speed of this body?
Zero.
Zero.
Yeah. So we will utilize that concept only, that when that will be a maximum, it will be zero. If I use this, okay, maybe here I can write. So acceleration is given a equal to g minus cy. Okay, and I want, so what is this acceleration? It is dv dt, or somebody can write dv dy multiplied by dy dt. Why I have written y? Because here it is given y. Okay, from there it is y. So dv dt, that means acceleration will be, and this is nothing but velocity. So it is v dv dy, or a dy equal to v dv. That relation we want to utilize. So what we'll write here, that a dy equal to v dv, or g minus cy dy equal to v dv. Let's do the integrations. So y is varying from 0. Initially it was 0. You look here. This was y. Initially it was 0. Then it will reach maximum value. What is the limit for y?
M.
ym.
Zero.
Ym will be maximum y. It is told, no, whatever the y, it will be the traveled, the body will travel in vertically downward. That will be the spring. That will be the spring compression. So it is up to ym, and velocity, variation of velocity. Initially it was v0. Finally it is 0. That one you have to utilize for this problem. Okay, so gy minus cy square by 2, 0 to ym, equal to half v0 to 0, sorry, v square. So when it is 0 ym, then gym minus c by 2 ym squared equal to half 0 minus b0 square, or we have to calculate the value of c, is not it? So if I want positive values, then if I want to move this way, c multiplied by ym square by 2, that side, equal to gym, this is plus v0 square by 2, or maybe cym square equal to 2. I'll multiply it by this 2 here, then 2gym plus v0 square. Okay, so c will be v0 square plus 2gym divided by ym. Okay, so that you have to show, this is the answer. So you have to calculate the value of c. C is the constant, and that is positive constant. Fine.
Yes.
Yes, sir.
Yeah. So then you have no doubt at all for problem sheet 1, correct? I can move to then problem sheet 2, is not it?
Yes, sir.
Yes,
Yes,
sir.
very good. Let me move problem sheet 2. Huh. In problem sheet 2, how many problems we can discuss now? Anybody can ask any issues. No problem, okay?
Sir, 5.
Five.
5.
1 minute. 5. Definitely 5 I have to give. 5. Then 5. Then
Sir, 4.
4. Yeah. 4. Then 1 is okay, no? You have done 1. Last day also I told. Then 2.
Yes.
Yeah, 2.
Done, sir.
Yes.
Done.
Done.
3.
Done, sir.
Done.
Done. 4. 5. 6.
We have
Done, sir.
discussed this,
Done, sir.
sir.
We have discussed. Yeah, yeah. It is so 6. What we will get basically? You will get some expression of R, range R, and for maximum value of R, dr d theta equal to 0, and d square R d theta square less than 0. Dr d theta will give that tan 2 theta equal to minus 1 by tan alpha. From that you will get relationship theta equal to 90 degree plus alpha divided by 2, or 45 degree plus alpha by 2. In 3 alpha, alpha equal to 0 corresponding theta, alpha equal to 30 degree corresponding theta, and alpha 45 degree corresponding theta. Okay. So in that case we have to solve only 4 and 5. Okay. Let's start for the 4. Okay. So for 4, let me read it. Particle is ejected from a tube. Yes. At A. At A. Screen is okay, or I should make it like this is better. With a velocity V. With a velocity V. At an angle theta. With the vertical y-axis. So this is the y-axis. This is the x-axis. Yes, a strong horizontal wind gives the particle a constant horizontal acceleration. So ax equal to a, that is constant in the x directions. So of course this ax will be along this. That is constant a. Okay. If the particle strikes the ground at a point directly under its release positions, so this to this, then determine the height h of the point A. The downward y accelerations may be taken as g. So this is g equal to ay. Okay. Or then what we can do, let's consider this is positive y downward. Then it is g will be ay, or reverse well, right? ay equal to plus g. Why plus g? Because y is downward we have considered. And this one I have considered x positive. That's why ay equal to ax equal to plus a. Okay. Now what we have to work for this? So this velocity v, you decompose into two component. This will be vx. Some theta is given, is not it? So this is the theta. So this will be the theta. So this Vx is V sine theta, left directions, and this is V cosine theta. This is Vy. So we got this Vx, Vy. Then Ax equal to A and Ay equal to G. Now the distance x is related to Vxt ut plus half Ax t square. This relationship it will follow. That means 0 equal to Vx is V sin theta. It is with minus. Why minus? It is these directions. And we are in positive directions we are calculating. So Vx, why positive? Because this x is positive. So minus V sin theta multiplied by t plus half. What is Ax? Is A t squared. Okay. That indicates t will be cancelled out because t cannot be 0, correct? It will be cancelled out. So t will be V sin theta 2 by A. V sin theta, it will be positive for that side, multiplied by 2 divided by A. This is the basically t, time required to travel from point A to point B. Time required to travel from point A to point B. Now we got t. Now what we will utilize, the vertical directions y will be Vy plus half g t square. Why? It is plus because y is downward directions and g was also along that directions. So it will be h equal to Vy is V cosine theta plus, oh I missed t, sorry.
T, sir.
Yeah, t.
You must be, sir.
Yeah. So let it be t is 2v sine theta by a plus half g 2v sine theta by a whole square. Okay. So if you take from this, you can check this. This is the 2. Here half 2 square means 4. So 2 we can take common 2. Here v square. So v square we can take common. Then here it is a. Here it is a. Here it is a square. Let take a common. Here it is sine theta square. Take sine theta as a common. Then you will have this cosine theta here plus this g by a sine theta. So this is the expression of h. So you have to be careful for solving this. Don't hurry. Okay. So whatever the thing is given and what are the theory has been discussed, class 10 plus 2 standard concept use with proper value of positive and negative sign. Which one is positive x, which is positive y. Based on that, ax is positive, ay is positive, vy was positive, but vx was negative. You take care of all this and nicely will reach to the correct answers. Okay. So problem 4 is okay, everybody?
Sir, okay. Okay, sir. Yes,
4.
sir.
Yes. Then these problems are relatively easy. Whatever problems we have solved in statics. In statics, there was mainly conceptual problem. Okay. In dynamics, just a little bit enhancement of your 10 plus 2 standard. Why? Because this is just for we are taking 10 hours class for dynamics. Uh, but for mechanical guys, aerospace, civil, metallurgy, they will learn higher version of dynamics, the like rigid body dynamics, separate subject. There they will go into deep in details. Okay, we are just giving some classic touch of the dynamics. Problems will be relatively easy. Okay. Not so much easy, but relatively easy. Okay. But okay, I cannot say this is very easy. No, relatively easy. Okay, fine. Now this is very interesting problems. Like there is one cathode ray tube. You can see this is the cathode ray tube, and there are some electron which is traveling horizontally. Electron is traveling horizontally here with some velocity v0. But this motion or trajectory of the electrons is being deflected. Initial velocity was v0, but it is deflected by an electric field E due to the voltage gradient across the plates. You can see this is the plate, this is the plate, okay, and here some gradient given from this to this. Some electric field is being given, and there is some voltage gradient across the plate. For that one, this electron movement has been deflected. The deflection forces causes an accelerations in the vertical directions on the scale equal to this. So acceleration in vertical direction is ay. Maybe we consider this is x, and so this is y. One is x, other is y. Okay. So if you consider x and y, then in positive y direction it has been deflected. You see the figure, it has been deflected. Ay, that acceleration was e capital E, small e capital E by m, where e is this e electron charge. So electrical guys can understand better. Electronics guy also understand this. Okay. So this there will be some acceleration in vertical direction due to the voltage gradient across the plate P. So if I ask, then what will be the value of Ax? What will be the value of Ax? Any idea?
0.
Very good. It is 0.
0, sir.
0. So when the plate when clear of the plate clear of the plates, the electron travel in a straight line. When it cleared of the plate means here this to this it is straight line. This to this it is straight line. Once again I am drawing. So here it is clearing the plate, it is straight line, because outside of the plate there is no influence, there is no effect of the voltage gradient. When it is inside, it is inside of the plate, there is a voltage gradient, so electron will deflect. Now if I simplify problem like this, say initially it was v0, then it's supposed to travel like this, but here there is one electric field. Okay, plate length is L, and when it clears, say here, from this it travels in a straight line. Maybe this is the straight line. I am drawing like this. And we have to determine the expression of the deflection delta for the tube and plate dimension shown. Tube dimension is B. length is B, plate dimension length is L, this is B, and this is delta. So maybe what I will do, delta I will decompose into two parts, this and this, delta 1 and this is delta 2. What is delta 1 and what is delta 2? Delta 2 is, it is easy for me to say that this to this, it is straight line. So electron, as it is moving in a straight line, when it will leave the plate, and that vertical distance is a delta 2. Now question is, do you have any idea if this to this, there is no horizontal accelerations. If there is any vertical acceleration, how the what will be the shape of the locus of the particle? Do you have any idea?
Parabolic.
Parabolic.
Parabola.
Parabola. Okay, so let me take different color. Yes. So this to this is, you assume this is a parabola. Or once again I'll try, it is parabola. It is parabola. So for parabola, this is delta 1. Okay. For parabola, that particle displacement traveled, that is delta 1. In exam, it has been asked, you have to write what is delta 1, what is delta 2. Okay. Now, Vx equal to always V0. Is not it? Because in horizontal directions, somebody can write plus axt and this is 0. So it is V0. The time, what is this? T equal to time required for the electron to travel plate length of L. L distance, when it will travel, the time is required is T. So Vx will be same. There is no change of Vx because Ax is 0. Okay. So if it is constant and time required is T, then this length S equal to Vx multiplied by T, or L equal to V0 multiplied by T, or T equal to L by V0. That time is required to travel that length L. L equal to T equal to L by V0. Now, what will be Vy? When Vy, let me consider here this place, this locations. One is Vx, other is Vy. So Vy will be, okay, so here for that one, let me write Vy, Vxt at time t, okay, Vyt equal to Vy means initial one is Vy, somebody can write Vy0 also, okay, so it will be Vy plus Ayt. What is Vy? Here.
0, 0.
0.
So it is Ay is small e, capital E by M multiplied by L by V0. That is Vyt. Okay. That was the VYT. Now the distance traveled delta 1 equal to Vy multiplied by T plus half G accelerations Ey T square. That is the distance traveled. Okay. So this is 0 equal to half Ay is small e capital E by M multiplied by L by V0 square. Okay. We understood that this is delta 1. Now, you use the logic. From this, there is no change of the directions. It is constant. And if somebody have this is Vx, sorry, Vxt, correct? And Vyt. At time t, then somebody can have this theta, correct? But tan theta, Vy t by Vxt is not it. Tan theta equal to Vyt by Vxt.
Yes, sir.
Yeah. If it is so, then this delta 1, you see delta, see what I told, if this is theta, then here it is also theta. Because once it has been fixed, it will move with this along these directions. Resultant velocity along that directions particularly will move. Is not it?
Yes, sir.
Yes, sir.
Yes. So if it is so, then this delta delta 2 will be, see, this delta 2 by B equal to tan theta.
Yes, sir.
So delta 2 will be B tan theta equal to B multiplied by Vyt. This is E small e capital E M T by V0 by Vtx. It is same as V0. Just a minute. Vy
L by V naught, sir, whole square.
that no, this is Vy. Vy is this Vyt, and Vxt was V0 only. Somewhere I have, this is Vxt is V0. So, now, B is B, tan theta equal to V. What is Vy? Vy is this.
L by V naught. You have written T by V naught.
Oh, sorry. Thank you. L by V naught. Yeah. So this is, so total delta equal to delta 1 plus delta 2. Delta 1 was half small e capital E by M L by V0 square plus B small e capital E M L by V0 by V0. So we can take common small e capital E by M. Let's take here, it will be V square, right? V0 square. Then V0 square we have taken here. So it will be here 1 L also you can take common. So L by, here it will be 1 L by 2 plus here EMLB. Yes, plus B. Yes, that is the expressions. So what we did, Total displacement delta we have decomposed into two parts, delta 1 and delta 2. Delta 1 corresponds to the vertical deflection due to the presence of electron discharge, presence of voltage gradient due to the electric field E, and that distance delta 1, to get the delta 1, what we did initially, so as Ax equal to 0, Ay was E small e capital E by M. So using this Ay, and in x direction Ax equal to 0, time required is t to travel the length L, length of the plate. So L equal to Bx multiplied by Bx multiplied by T, and then T equal to V0 by L, correct? So T equal to, sorry, L by V0, and using that T we have to calculate what is the velocity Vy. Then based on that, what is delta 1? You will get the delta 1 expressions. Next one is for delta 2, as it is not been affected by any of the electric field, it is straight line. So when it just leave the plate, let's have velocity Bxt and Vyt, and that they are making angle theta. So tan theta equal to Vyt by Vxt. You put the relationship and get delta equal to delta 1 plus delta 2. Okay. Done, no? Is it okay?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Yes. So next problem. So problem sheet 3. What are the problems you want? What are the problems I have to show you? I think last day I have shown these 3. And this is done. Sorry. This is done basically. This is done. This is done. This also done. Okay, now tell me, what are the problems you need help from me?
Fourth.
6.
4. Okay, one is 6. Yes, definitely 6. Then
Sir, number 4, sir.
number 4.
Four.
Yes, this is 4. Okay. So let me note down 4 and 6. Okay. 4 and 6. And 2 you can easily do. Okay. Somebody did this problem, no? Solve, no? These 2?
Yes, sir. Yes, sir.
Yes. 4 and 6. Okay. Let me start here. It is told that the motion of a pin A, this is the pin A, okay. In the fixed circular slot. So we have the fixed circular slot. So this is the slot, okay. So there is some cutout here. Through that the pin can travel, and the motion of the pin A in the fixed circular slot is controlled by the guide B. This is the guide B, which is being elevated by its lead screw. Actually, we used to, this is the lead screw. Using this lead screw here, this is the screw. You will know later, okay, details of this type of things. So this is moving with some constant velocity V0 in upward directions for an interval of its motion. Calculate both normal and tangential component of the acceleration of the pin as it passes the positions for theta equal to 30 degree. So this is the theta. This position we have to tell. So when theta equal to 30 degree, normal and tangential accelerations we have to calculate. Okay. Now, there's very fine examples. In reality, many components, just like this type of pin, is being used for some to control some sort of the motions of any automobile or many other application also. Okay. Basically, in shop floor, many applications are like this. So it is understood that if the guide B moves with some constant velocity in vertical directions v0, then this pin has to follow this circular slot path. It cannot move as is shown. Only that along the slot it can move. That is the only option given. It can move along the slot. Okay. Now, in many ways we can solve this. One is I want to delete this once again. I'll draw here itself. Okay. So let me draw for this particular case along this line, central line. It will be AN, normal accelerations. That I have told, correct? Along that line, it will be normal acceleration, AN. Then, if somebody can draw perpendicular line, along this will be A T. So normal and tangential. So somebody can say this is normal directions and this is T directions. Now, can you tell me the instantaneous velocity will be in which directions?
Upward.
Huh?
It's a tangential.
Tangential. Very good. So we'll draw here. This is velocity v. This is the velocity v. Okay. Now we understood this is the velocity v. Now actually this v0, if I draw here itself, this is the v0 directions. I am drawing here. You can show in separate drawing. Okay. This is the v0. And if this is theta, this also will be theta. So your v will be, okay, if it is v0, this is the v. Sorry, this is v0 given, then that is the v, tangential. So from this figure, you can say this v0 is, okay, one thing I can say. So which one is higher value, v or v0?
V0.
v0. Okay. You going to show v0 is the higher value, not v. Okay. So then I have to tell that no, v is higher value because v is always constant. So some value is given. Let me write it. v0 equal to 2 meter per second. You imagine this scenario when there is some velocity, vertical velocity, then whatever the distance traveled by this glide B, okay, this pin also will travel the same distance or a higher distance?
Same.
Higher.
B is traveling vertical directions. B.
Yes,
But
sir.
this
B lower. A will travel more
higher because
distance.
travel will be more. Okay. Then whatever the time, for the same time, which one is traveling more?
A.
And velocity
A should be greater.
B is higher than the V0. Correct. So and this V basically V0 by cosine theta. So 2 by cosine 30 degree. It is 2.31 meter per second. That you understood. B is higher than that. Now, what is An then? V square by rho 2.31 whole square by rho. What is the rho? 250? Is it?
Yes, sir.
No,
Millimeter.
250 weight? Yes, 1000. Okay. So you will be getting some value to 21.3 meter per second square. No issue up to this, correct? Now, AT. What is the value of AT? Okay. What is the value of AT? Okay. Now tell me, we got AN. Okay. AN is fixed. Now AT supposed to be AT is supposed to be which directions? Along the positive T or negative T?
Positive.
Okay, well, I can tell this way also.
Positive.
Okay, positive T. Okay, fine. Now tell me, if I use the positive T along that AT is along that positive T, okay, then what is the total, A total, acceleration total? A total basically, vectorically basically, A N and AT.
Yes, sir.
Yes, sir.
Now, what is your understanding for this problem? A total will be which direction? Let me tell you. You have two options. This is the A total, odd. This is the A total. Which one will be there? A total. When there is any glide like this, it is following that path. A total will be this.
What case, sir?
A total will be this or this. Case 1, case 2,
One.
1.
One word.
Okay,
One.
if you think that you are at the position of the pin, okay, and many times merry-go-round somewhere you have seen like equivalent things, and it is moving. Then what is will be your feeling? You will be towards the center or away of the center?
Away.
Okay. There are say one is if it is following this means I want this is the AT and resultant is this. Here I am drawing. And if it is this, then resultant is this. Resultant is this. Which one will be true?
Hello, sir.
Tell me.
Hello.
Yes, tell me.
Sir, your voice is lagging, sir. We can't hear anything.
Just a minute. Okay. Are you able to hear me now?
Yes, sir.
Yes,
No,
sir.
sir.
Yes,
Yes, sir.
I understood.
It's not
Exam has
audible.
Yes,
started.
sir.
Exam has actually I am now in institute. Exam has started. Okay, so many I think faculties are at the institute taking taking the class. So our bandwidth is being having some issue now. Understood? Okay, just a minute. Wait. Okay. Okay. Are you able to hear me now?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
Okay,
Yes,
fine.
sir.
So, see, thing is, there are two ways. One is resultant is this, otherwise resultant is this. Okay. Maybe if you have any confusions, don't worry. Actually, this is uh, okay. Both way I'll show you. Or maybe like this and this and this. This is AN. This AN. Maybe this is AT. This is AT. AN. AT. Drawing like this. AN. AT. Okay. One thing I can say, now look, this movement of this particle of the pin is mainly due to that V0, correct? Only one movement you have, correct? V0.
Yes, sir. Yes, sir.
If this is only due to V0, then it is been you can expect that only one movement guided by V0, you can expect that total accelerations will be perpendicular to the V0. A total. Have you understood this point? If it is V0, then total acceleration will be perpendicular to the V0 because V0 was the instantaneous velocity for B, for guide B. For guide B, V0 is the instantaneous velocity. Then total accelerations
Yes.
is hello? Yeah, fetching issues. Hello?
No, sir. Right.
No, sir.
Okay. Now concentrate this way. V0. This is the governing driving velocity. And if you are using V0, then you can expect that total accelerations at any instant is perpendicular to the V0. This assumption is required for solving this.
Yes, sir. Right.
If it is so, then I can erase everything now. Just a minute.
Total is towards to pin.
Once I'll draw it, you will understand. So this is total A0. This is total A0 and this is AN, and if you draw this, this is AT, this is A total. So this is AN, this is AT, and if this is 30 degree, this is theta. If this is theta, this also will be theta. So tan theta will be here. Tan theta will be A T by AN, and AT will be AN tan theta. That means AN we got some value 21.3 multiplied by tan 30 degree. You will get 12 point whatever is given meter per second square. Here negative sign indicates this was our positive T, this was positive N, this was velocity V. As this is towards minus T directions, that's why it is negative. So see, to get initially from V0 to V was very straightforward. Then getting AN equal to V square by rho was very straightforward. One trick of this problem is, as we are applying only V0 outside velocity, governing velocity, then total acceleration will be perpendicular to that velocity. So it is horizontal leftward directions. If that is the A total, then A tangential you will get from the rectangle, and tan theta will be AT by AN. So AT will be AN tan theta. Got it? Or should I explain this point once again?
Understood, sir.
Yes, yes. Only trick is this V0 is vertical direction, so AT is perpendicular, A total is perpendicular to V0. The remaining thing is you can do. Then you told 6, problem 6. Yes, this is also one good problem. Problem 6, there is one pin P that is constrained to move in the slotted guide. So this pin so there are one horizontal slot, one vertical slot. Pin is P. For this one, it is at the instant represented guide A. This guide A, which is A has a velocity right directions VA 0.2 meter per second, which is decreasing at the rate of 0.75 meter per second each second. Meter per second each second means meter per second square. That is decreasing. Means it is having a deceleration. If we consider this is positive X, this is positive Y, say for example, so BA is positive and acceleration is AA in these directions. Okay, negative means in other directions, and that is 0.75 meter per second square. At the same time, B is moving, this is moving downward. B is moving downward at velocity VB 15 meter per second, which is decreasing at the rate of 0.5 meter per second each second. So it is moving down. So decreasing means acceleration will be in upward directions, 0.5 meter per second square. For this instance, determine the radius of curvature rho of the path followed by P. So it is P is experiencing some complicated movement due to movement of A with the rate of 0.2 meter per second horizontal directions, acceleration in negative direction horizontal A equal to 0.5 meter per second square. B is moving downward, VB downward 0.15 meter per second. Acceleration is negative, so it is upward 0.5 meter per second square. We have to calculate the value of rho, radius of curvature. Is it possible to determine also the time rate of change of rho? Time rate of change of rho means rho dot. Time rate of change is rho dot. It is possible. Okay. Now let me draw velocity diagram. So in velocity diagram says 0.2, 0.15. So BA 0.2 meter per second. BB 0.15 meter per second. Now you can have resultant here. This is the resultant. This is B basically. So somebody can write B equal to square root BA square plus BB square. Okay. Now that is 0.25 meter per second. We have calculated that. Now what is the direction of resultant? V. That is, if it is theta, tan theta equal to 0.15 by 0.2, 15 by 20, 3 by 4. Tan theta equal to 3 by 4, somebody can calculate value of theta. Okay. Some books, somebody can write this way also. This is 3, this is 4, and this is 5. This way. 5, 3, and 4. Now, you understood if this is the V. So, which one is tangential and which one is normal? Tell me now. Which one is tangential and which one is normal? Directions. This is what directions? Normal direction or tangential?
Normal.
Tangential.
Along velocity.
Tangential.
Tangential, and this is normal. So once you know this normal and tangential directions, so this is T, this is N. As I told, this for A, this is the directions or accelerations we have. A 0.75 meter per second square. What is B? Moving down decelerations. So this way. AB 0.5 meter per second square. Okay. Now somebody can use this 3 by 5 concept. This is 5, this is 3, and this is 4. Okay. Now AN will be AN normal directions. Okay. It is 0.75 multiplied by If it is 3 by 5,
Cos 53.
okay, 3 by, so this is normal. This is 3 here, if I write this way. This is 3, this is 4 and 5, correct? So,
4 by 5.
basically, as you told, no, sin theta was 3 by 4, okay?
3 by 5.
Sorry, 3 by 5, huh? And cosine theta equal to 4 by 5.
4 by 5.
So, it will be, yes, 3 by 5. An minus 0.5 multiplied by 4 by 5. We will be getting 0.05 meter per second square. An. Now, v square by rho equal to an. So, rho will be v square by an. V equal to, we have found this 0.25 square by 0.05. It will be 1.25 meter. Rho we have calculated. Now, what is the value of AT? AT, this is the positive T. So, it will be minus 0.75 multiplied by 4 by 5 minus 0.5 multiplied by 3 by 5 equal to minus 0.9 meter per second square. Next question, this AT value we have calculated. Now, this AT basically dV of dt. That is d by dt of rho multiplied by theta dot. That is velocity. Rho multiplied by theta dot equal to rho theta double dot plus rho dot theta dot. That is the AT. Rho multiplied by theta dot plus rho dot theta dot. Okay. Now, this theta dot equal to this theta dot equal to rho theta dot equal to v equal to rho theta dot. So, sorry, theta dot would be v by rho. So, rho dot v by rho. Now, you look here, AT is known, we have calculated, known parameter. V, known parameter, or I should write once again, AT equal to rho theta dot plus rho dot p by rho. This one, known parameter. This known parameter. This is also known parameter. Rho, known parameter. Whether we can calculate the time rate change of rho dot can be calculated. To calculate rho dot, we need one unknown theta dot also,
Yes.
which is not available for this configuration given. Accelerations, rotational acceleration, sometimes we write alpha, correct? From this data provided, we cannot find out theta double dot. That's why rate of change of radius of curvature, rho dot, cannot be calculated. Is it okay? Have you understood this point? Or I can explain once again. What I did, very interestingly, whatever VA given with the directions, 1 minute. I have shown this VA. This is the VB. So I can easily calculate V value, that is square root of this, and this is the value. What direction it is acting? Tan theta equal to 3 by 4. So 3, 4 and 5. So we can get sin theta and cosine theta. Now, as the velocity is acting along this, that will be tangential directions for NT configurations. So this is the positive T directions. So this is the N directions. Somebody can have other direction N also, no issue. Okay, somebody can have this N also, no issue. But T is fixed, positive T. And this is the N. So if it is T and N, what I can do? I can write this is the T and this is the N. Okay, this is the one accelerations, AB, this is the AA. Now I can decompose these two accelerations to normal and tangential directions. First of all, let it be in normal directions. An is nothing. N we can calculate 0.5 meter per second square. That is nothing but b square by rho. Rho, that is nothing but v square by rho. V we know velocity. This velocity 0.25. So rho can be calculated. Then AT, similarly AT, tangential acceleration also we can calculate. But this AT equal to dv dt, v equal to rho theta dot. So rho theta double dot, rho dot theta dot. Rho theta double dot, rho dot theta dot equal to v by rho. So finally AT equal to v rho theta dot, rho theta double dot plus rho dot v by rho. We know v rho AT, but rho dot cannot be calculated as we don't know rate of change of theta for the given problems. Some data, additional data is required to determine time rate of change of rho. It is very it is very complicated equations, but for that equations, given the conditions, some boundary conditions, some of some portion of the trajectory we can calculate. This is the AT, this is the AN, but we cannot calculate rate of change of rho, radius of curvature, due to the complexity of the trajectory of point of pin P, although it is 2D problems. Okay. Is it okay, this problem?
Yes, sir.
Okay. So then, yes. Then this problem 5, this one I have solved there. This one also I have solved. So do you need help from me? 2 or 3?
So 3, I'm having some problem.
Okay, okay, fine. Okay, let's do this both 2 and 3 here, because we have some time now. So what we can do, this type of problem, determine the relationship that governs the velocity of the 4 cylinders, express all velocities as positive down. Okay, how many degrees of freedom are there? How many degrees of freedom here?
Sir, 1 only.
Why? Okay, okay, let it be fixed, this one A. Okay, don't move this point A. Is it possible to move D?
Yes, sir.
Okay, now fix D. Okay, fixed only D. Is it possible to move A?
Yes, sir.
Yes,
Okay,
sir. Move.
so at least okay. Now you fixed A and D both. Okay, A and D. So A and D both you fixed. Is it possible to move C?
No, sir.
No, sir.
Okay. So I mean to say, if you fix this and fix this, if I fix this, that means fixing this indicates this we cannot change, correct? Is not it?
Yes, sir.
Yes.
Yes, sir.
And fixing this EM is this we cannot change. Now, can we move C?
No, sir.
Okay. Little bit. Once again I can check. I can tell. Say fixing D. Fixing D. Okay. Means we are fixing this. So this point is fixed in that case. Once again I'll tell you step by step. And that indicates this point is fixed. Okay. If I fix D, if I fix D, then this the point I have shown, this point is fixed. That is confirmed. Okay. Now if I fixed A, then this point is see when I fixed D, everything is fixed. I should write this way. Okay. Understood? If I fix D, that mark,
Yes, sir. That pulley can't go up or down.
and if I fixed D A, then this point is fixed.
Yes, sir.
But I can move C.
Yes, sir.
Understood? Here it was one
Sir,
degrees
can
of
you
Yes,
freedom.
explain?
sir. There's another pulley on the top
Ha.
that can move.
So only this is fixed. Okay, this point. But I can move C. So it is 3 degrees of freedom. Only another movement is possible. Because if I move C, actually this is it is floating basically. Understood? With this one. So if I move down this will be little up. If I move C up, this will be little down. Although this point is fixed, due to A is fixed. So
Yes, sir.
degrees.
The string would be lag
Yes,
or tight.
yes. Not no. I'll tell you what I told, that up to this it is fixed. Up to this it is fixed. That is fine. But this point, this pulley itself can move or down due to this. It will not be lag. Always it will be in tension, because due to the cell point it will be always in tension. But if you change the position of C, if you change position of C, then the position of B will move, because there will be some relative movement for this and this. I will erase once again. I'll show you. So what is happening? How many cables you have here? How many cables you have here?
3, sir.
3. All,
3.
yes, all cable is having their own 1 degrees of freedom. Okay. So we got DOF equal to 3. Now, maybe anything I can do. I can consider here also reference, or maybe I can use this as the reference. I can use top also as the reference. Okay. You can do whatever you want. So this is a YD, and this is YA. This is YB. Why I have taken this? Because this is constant, I know. This is also constant. That's why I can write here YC. Then Y2. This is Y1. So three cables we will write down that this is the cable 1, this is cable 2, and this is cable 3. For L1, cable 1, this is 1, this up to this. That will be Y cable 1 is this. This will be YB. This is YB plus YA. This is the YA plus YB minus Y1. This is also
Y1.
flexible, yeah. Plus some constant, okay. Constant due to this radius. So this was L1. Then L2 was, this is L2. YC plus YC plus YC plus Y1 Y1 to Y1 plus this is Y2 YC minus Y2 plus some constant. So YC, sorry, YC. For 2 it is, one second, this is the YC, this to this YC plus 2Y1, this and this plus this YC minus Y2. This is Y2 constant. And L3 is YD plus Y2 plus Y2. This is YD, Y2 plus Y2 plus constant. From this relationship, you can get 0 equal to 2YB dot plus YA dot minus Y1 dot. Second one, it is 2YC dot plus 2Y1 dot, sorry, minus Y2 dot. Last one, 0 equal to 2Y2 dot plus YD dot. Now, if you eliminate Y1 dot and Y2 dot, because Y1 dot, Y2 dot was here, Y2 dot, Y1 dot, some auxiliary constant we have considered. If you remove this, and some dot you represent by velocity, then relationship will be VA, 4VA plus 8VB plus 4VC plus VD equal to 0. Little bit complicated constant equations. So what I did, based on some Y1, Y2, sorry, YA, there are three string, 3 degrees of freedom. L1, L2, L3 are the length. So L1, L2, L3 we have written in terms of YA, YB, YC, YD and Y1 and Y2 plus some constant. And if you do the derivative, you will get the velocity. Now Y1 and Y2 are the auxiliary variables. If you remove that, then you can get relationship between VA, VB, VC and VD. 4VA plus 8VB plus 4VC plus VD. If one is increasing, other will decrease. From this relationship, you can say. That is done. Last problem is remaining, okay? That is this problem, correct? Okay. Remaining is question 3, is not it?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, yeah. Let me erase this. So the syllabus for your class test is over once I have solved this. Okay, I am not increasing the syllabus. Syllabus let it be same. Okay, so that you can score better. At least you should have some out of two, one class test having good marks. Okay, so for this problem, so oh, it has started here. Under the action of force P, this is the force P. Okay, just 1 minute, just wait. Okay, so P is moving and the constant acceleration of the block B, that is constant accelerations 3 meter per second square to the right. Okay, determine the velocity of B relative to A, the acceleration of B relative to point A, the absolute velocity of point C. So what we can do, we can consider some reference point anywhere, maybe from here, and let it be this distance here. It is SA, SC, this distance, this is SB, okay, I missed this. So instead of this, let it be this is SA, SC, SB, and P we have applied. So degrees of freedom,
One.
One.
okay, I think I told no, one thing is missing here, velocity BB. That was missing,
Oh,
I
yes,
guess.
yes, sir.
Yeah, last I told, correct? So what is the degrees of freedom?
One.
One.
1. So which is missing, I told BB equal to 2 meter per second square. And it is given accelerations, meter per second. This velocity. Accelerations AA, that is given 3 meter per second square. Okay, and this is the
Sir, I think AB is given.
AB, no? Yes. Thank you. AB is given. Yeah, AB is given. BB was missing. I told later. Okay, so I'm removing right.
Two, sir.
Yeah, so cable length L was and somebody can have this point also, this distance SD, although this SD is constant. Okay, SD is constant. So total length is step by step. If I go this one, this one, this one, 3 times SB minus SA, 1, 2, 3, plus SD minus SA, this one, plus SD minus SA, plus some constant. So 0 will be 3 VB minus 3 VA
4B.
minus VA, correct?
Yes, sir.
So it is 3 VB equal to 4 VA, or VA equal to 3 by 4 VB. Yes, 3 by 4 VB. 3 by 4 multiplied by 2. So 1.5 meter per second VA. Okay, 1.5 meter per second. Now, what is the accelerations? Or similar way, 3 AB equal to 4A. So A will be accelerations 3 by 4 AB 3 must given 3 by 4 2.25 meter per second square. Meter per second square. Acha. Then relative velocity, it has been asked. VB by A will be VB minus VA. What is VB velocity? VB is given to VA is 1.5.
1.5.
Yeah. So 0.5 meter per second. Which directions? VB minus, yes, right directions, correct? Towards right.
Towards right.
Right, right.
Towards right.
Towards two direction of VV.
Mhm. Towards towards, yes, direction of B. Okay. Towards right is also fine. This is the first problem. Next problem told that absolute velocity of point C. C is the midpoint. So for this, if you consider L prime is the length, L prime is the length, either this up to this or maybe lower portion. Anything is fine. This length up to this length, L prime. That length is SB minus SA for top, this to this. Here plus SC distance minus SA
SA.
plus some constant. Okay. So 0 will be VB minus VA plus VC minus VA. Okay. That means this VC equal to 2 VA plus VB, absolute velocity. Okay. 2 multiplied by VA 1.5 plus VB 2, 3, 5.
Sir, minus VB, right?
Minus, yes. VC is this. This is minus. BC, if I took this is minus. This is minus. Okay. So 3 minus 2, 1 meter per second. Positive towards right. Okay.
Yes, sir.
Okay. That's all. So we have finished. Okay, very good. So your midsem, next class test will be after this only, as I told earlier. So date we have decided today, 22. Okay, 22. 22. So let me check. This is the 20. And which date you will be coming to the institute?
6th April, sir.
Sir, after 6, sir, April.
Fine, no problem. No problem. We have time. So as per my plan, I will finish the syllabus by April 1 itself. Okay. So that was previous plan wise. So next day we'll discuss new concept, that is dynamics. That is dynamics. Kinematics is over. Remaining is kinetics, and only we'll cover. Let me tell you, we'll cover sequence wise. Is problem sheet sequence I'll not maintain. I'll a little bit change this sequence. So we'll move. Use note down 3 by 4, 3 by 5 article, 3 by 8. Sorry, 3 by 6, 3 by 8, then 3 by 12. 3 by 4 will be problem sheet 11, not in sequence wise. 3 by 5 will be problem sheet 7, 3 by 6 will be problem sheet 6, 3 by 8 will be problem sheet 10, and 3 by 12 will be problem sheet 8. So in this sequence, I will cover the syllabus. 5 problem sheets remaining, 3.4, 3 by 4, 3 by 5, 6, 8, and 12. And you can see problem sheet 6. So I will not solve this one first. First I will solve problem sheet 11. I have provided you this one also. 11 was, yes, so that kinetics rectilinear motions. Okay. Then problem sheet 7. Problem sheet 7, that is kinetics curvilinear motion. First was rectilinear, now curvilinear. Then problem sheet 6, yes, work and energy, kinetic energy. Then problem sheet 10, impact and momentum. Then problem sheet 8, yeah, that was impact. So that way I have planned to cover the syllabus. Okay, fine. Guys, yes.
Okay, sir.
Yeah, tell me. Any question?
Yes, sir. I joined a little late, sir.
Okay, just a minute.
Sir, I also joined late, sir.
Okay, just a minute. Tell me roll number.
ITV 062.
IT
Sir,
62.
AMB 029, sir.
Just a minute. IT 62, correct?
Yes, sir.
Next.
Sir, AMB 029, sir.
Just a minute. Civil
80.
80.
ATB 042, sir.
Just a minute. Civil 80. Sudipto, correct?
Yes, sir.
Okay, given. Next.
Sir, AMB 029.
29. Yes, Somukanti. Given.
Thank you, sir.
ETB 042, sir.
ETB means electronics, correct?
Yes, sir.
Yes, given. Okay, that's all. So see you next day with new chapters, kinetics, and corresponding problem sheet also I told. Okay. Okay, guys.
Thank you, sir.
Thanks for your patience. Bye.
Thank you, sir.
Bye. Yeah.
Thank you, sir.
Thank you, sir.
Bye.